Hi all, I am Disha Shukla and welcome to the session. CDMA, that is Code Division Multiple Access. Now, it is a channel access method used by several radio communication technologies. It is a digital cellular technology and an example of multiple access. Now, it is generally used for the mobile communication. Multiple access means that several transmitters can send the information simultaneously over a single communication channel. In this system, different CDMA codes are assigned to different users and the users can access the whole bandwidth for the entire duration. It optimizes the use of available bandwidth as it transmits over the entire frequency range and does not limit the user's frequency range. It does not limit the user's frequency range. So, the CDMA allows several users to share a band of frequency without undoing the interference between the users. It is used as an access method in many mobile phone standards. Now, it stands for CDMA. CDMA is a wireless transmission technology that was developed during the World War II by the English allies to avoid having their transmissions jammed. And hence, after the World War ended, Qualcomm patented this technology and made it commercially available as a digital cellular technology. And now CDMA is popular communication method used by many cell phone companies. Now, unlike GSM and TDMA technologies, CDMA transmits over the entire frequency range available. It does not assign a specific frequency to each user on the communication network. This method called multiplexing is what made the transmission difficult to jam during the World War II. And because CDMA does not limit each user's frequency range, there is more bandwidth available. This allows more users to communicate on the same network at one time than if each user was allocated a specific frequency range. Now, because CDMA is a digital technology, analog audio signals must be digitized before being transmitted on the network. And CDMA is used by 2G and 3G wireless communications and typically operates in the frequency range of 800 MHz to 1.9 GHz. Now, CDMA is a digital cellular technology that uses spread spectrum techniques. Unlike computing systems such as GSM and TDMA, CDMA does not assign a specific frequency to each user. And besides that, as the GSM and TDMA assign some specific frequency, in CDMA instead, every channel uses the full available spectrum. Individual conversations are encoded with the pseudo-random digital sequence. CDMA consistently provides better capacity for voice and data communication than other commercial mobile technologies, and hence allowing more subscribers to connect at any given time. And it is the common platform on which the 3G technologies are built. CDMA is a military technology first used during the World War II by the English allies to foil the German attempt at jamming the transmission. The allies decided to transmit over several frequencies instead of one, making it difficult for the Germans to pick up the complete signal. Because Qualcomm created the communication chips for CDMA technology, it was private to the classified information. Once the information became public, Qualcomm claimed the patent on technology and became the first to commercialize it. CDMA technology is used in commercial cellular communication to make better use of radio spectrum when compared to the other technologies. This technology was used as a military technology for the first time in World War II. CDMA technology is known as the spread spectrum technique, which allows many users to occupy at the same time and frequency allocation in a given band and space. Individual conversations are encoded with the help of pseudo-random digital sequence. CDMA has a number of distinguishing features that are key to the spread spectrum transmission technology. The first one being use of a wideband. Now, CDMA, like other spread spectrum technologies, uses a wide bandwidth than would otherwise be needed in the transmission of the data. This results in a number of advantages, including an increased immunity to the interference or jamming and multiple users. The another feature is spreading codes that are used. Now, in order to achieve the increased bandwidth, the data is spread by the user by the use of a code which is independent of the data. The third feature is the level of security. Now, in order to receive the data, the receiver must have a knowledge of the spreading code. Without this, it is not possible to decipher the transmitted data, and this gives a measure of security. And multiple access being the most important one. Now, in the CDMA, as I already said, that the users are given different codes using which the user will be, the users are divided. So the types of codes that are given are the first one being the PN code and the second being the truly orthogonal codes. Now the PN codes are the pseudo number codes. These codes will sum to 0 over a period of time. Although the sequence is deterministic because of the limited length of the linear shift register used to generate the sequence, they provide a pseudo number code that can be used within a CDMA system to provide the spreading code required. Now, pseudo random number codes can be generated very easily. The feature of a PN code is that if the same version of the PN code are time shifted, then they become almost orthogonal and can be used as a virtually orthogonal code within the CDMA. The another type of the code is the truly orthogonal codes. Now here the two codes are said to be orthogonal if they are multiplied together. The result is added over a period of time and then they sum up to 0. So when can you call the two codes orthogonal is that whenever you take two codes and then when they are multiplied together and the result is added over a period of time and then the sum that we get is 0, then you can say that the codes are orthogonal. Suppose we can say that, for example, we have the codes like minus 1, like we have the codes 1, -1, and 1, and the another is 1, -1, 1, -1. Now when you multiply the two, you get 1, 1, -1, -1, which gives the sum 0. So this is an example of an orthogonal code. That is, you are going to multiply the two codes and then you are going to add the result that you got. If you get a 0, then that is called a code division multiple access. So these are the two types of code that are given to using which the users are differentiated. The first being the pseudo number code and the second being the truly orthogonal codes. Now moving on, the advantages of CDMA are that CDMA has a soft capacity. The greater the number of codes, the more the number of users. It has some advantages like that the CDMA requires a tight power control as it suffers from near-far effect. In other words, I can say that a user near the base station transmitting with the same power will drown the signal later. All the signals must have more or less equal power at the receiver. Rake receivers can be used to improve the signal reception. Delayed version of the time, a chip or later, of the signal can be collected and used to make decisions at the bit level. Flexible transfer may be used. Mobile base stations can switch without changing the operators. Two base stations receive mobile signals and the mobile receives the signal from the two stations. And the transmission burst, it reduces the interference. But along with this, there are some disadvantages of CDMA too. Naming them, the code length must be very carefully selected. A large code length can induce some delay or it may cause interference. The another disadvantage is that time synchronization is required. Now here, as it is not divided based on any time or frequency, simply you are providing the codes. You need to synchronize the time at both the receiver and the sender side. Gradual transfer increases the use of radio resources and may reduce the capacity too. And as the sum of the power received and transmitted from the base station needs constant tight power control, this can result in several handovers. So these are some of the disadvantages of a CDMA technology. Now as you can see here that we are providing different codes, for code 1 for user 1, code 2 for the another user, and similarly code n for some other user. So as you can see that in the time and frequency you are providing different channels, and hence the graph is generated like this. CDMA is in which each channel is assigned a unique code which is orthogonal to the codes sent by the others. So this is all about the CDMA, a very important topic here. Summing up together, I would like to tell that CDMA is something wherein you don't divide the users based on frequency or time or space, nothing. But you simply provide each and every user a certain kind of a code, and using that code the users will be divided. Now these codes are here called the orthogonal codes or the pseudo number codes, and they are such that using those codes, when you transmit the data, you have to use the same code at the receiving side for deciphering the whole text. If you are not clear about this, you can ask me. Until then, keep learning.